All right, so last night you watched a video, an Ed puzzle on imaginary numbers. Okay, it introduced imaginary numbers to you, and it went over numbers 1 through 5. So what we're going to do is we're just going to continue on. So if you can go down to number 6, I'd actually like you to hit pause and try out 6 and 7 on your own. Okay, so with number 6, now what I'm going to do is I'm just going to take this -5 that's on the outside of the radical, and I'm going to bring that down. And since, I'm going to say positive 108 for a minute, since positive 108 is not a perfect square, we know we're going to need 2 radicals to separate that with. And then also we're going to need a third radical to take care of this negative sign. Okay, now, 108, positive 108, okay? We want to come up with the biggest perfect square that divides evenly into 108. So the biggest perfect square that divides evenly into that is 36. So I'm going to put a 36 here, and since 108 divided by 36 is 3, I'm going to put a 3 here. Okay, 36 times 3 gives us 108, but now we have to take into account that negative sign. So that's where our third radical comes into play. We're going to put a -1 under the third radical. Okay, so from here, I'm just going to bring down the -5. And let's think about this. The square root of 36, I'm going to just change colors here. All right, the square root of 36 is 6. So I'm going to cross that off and make it a 6. This is not a perfect square, okay? This we can't really do much with. We're going to leave that as a radical 3. But if you recall from last night's video, the square root of -1 is I. It's our imaginary component. So I'm going to cross this off and make it say I. All right, so basically what we have here is I had already brought down the -5. So now I'm going to bring down the 6i. I guess I'll put that in a parenthesis to separate it from the -5. And this radical 3 comes right down with it. Okay, so now we're going to multiply the -5 times 6, which is -30. And because there's an I attached to that, we can write it as -30i and bring down the radical 3. So there's number 6. Okay, number 7, I mean, honestly, it really is the same thing. You're just dealing with 2 radicals instead of 1, and you're going to add them together in the end. Okay, so let's start with the first radical. So let me bring down the 1/6. Oh. And then since 48 is not a perfect square, I know I'm going to need 2 separate radicals to break that up into. And then because we have a negative symbol, a negative sign, -1, right, I'm going to need a third radical for that. Let me just put the -1 in there right now. All right, so now there's, a few different perfect squares that divide evenly into 48, but the biggest perfect square that divides evenly into 48 is 16. So 16 times 3 gives me 48, so I'm going to put a 16 in one of the radicals and a 3 in the other. Okay, now I'm going to go through, and since the square root of 16 is 4, I'm going to cross this off and make it a 4. And since the square root of -1 is I can cross that off and make it an I. All right, and the radical 3 doesn't simplify. So as of right now, we have 1/6 times 4i, and I'm going to stick the radical 3 at the end. So 1/6, I'm going to just put this in parentheses, times 4i, and then I'll bring down the radical 3. Okay, now I'm going to take this plus sign and bring it down. Okay, and I'll bring it down, I guess, right here too. Okay, so I'm going to bring down the 1/3, and let's look what's under the radical. We have a -12. Well, since 12 is not a perfect square, I have to break that up into 2 separate radicals. And then since we have a negative under there, we have to make a third radical for that -1. Okay, so then the biggest perfect square that divides evenly into 12 would be 4. So since 4 times 3 gives me 12, I'm going to put a 4 in the first radical and a 3 in the leftover. All right, so now the square root of 4 is 2, so let's cross that off and make it a 2. This radical 3, we can't do anything with, right? We can't simplify it. But the square root of -1, we had already learned, is I. So let's cross that off and make that an I. All right, so I'm going to bring down the 1/3. And then times, I'm going to arrange the 2i in front of my radical 3. Okay, so now we need to do 1/6 times 4, right? We multiply these numbers. I'm going to make this 4 over 1, just so we can see how this works. All right, so if we were to multiply this, right, 1 times 4 is 4, and 6 times 1 is 6. When we multiply, we get 4 over 6. And doesn't 4 over 6 simplify to 2/3? So I'm going to rewrite this as 2/3, and then I'll bring down the I radical 3. Okay, then we have plus. Now let's do the same thing over here, right? Let's multiply 1/3 times 2. So let me take this 2 and put it over 1. And when I multiply these fractions, 1 times 2 is 2, and 3 times 1 is 3. So we get 2/3. All right, so this one is also 2/3. And then I'll bring down the I radical 3. Okay, now these are like terms. And the reason they're like terms is because they both contain an I radical 3. Right? The number in front of them doesn't have to be the same, but they both have to have an I radical 3 in order to be like. Okay, if one had the I and the other didn't, or if one was a radical 3 and the other was a radical 2, they wouldn't be like terms. But because they both have I radical 3, they say the same exact thing. If you want to add these together, all you do is just add the numbers in front. So 2/3 plus 2/3. Remember, when you add fractions, you add the top and you keep the bottom if they have a common denominator, which they do. So this will be 4/3. Right, 2/3 plus 2/3 is 4/3. And then we keep what they have in common. So we keep the I radical 3. So our final answer would be 4/3 I radical 3. Okay, if you flip to the next, actually really 2 pages. Okay, I'm going to start on this page. The regular and lab classes are going to do 1 through 7 odd. And then the accelerated classes are going to do that, plus you're going to try number 8 on your own. And then with the accelerated class, you are going to look on the answer key to see how you did on number 8. Okay, so we're going to start with number 1. Now, first thing, let me just talk about what a complex number is. A complex number, okay, you see at the top of the page, is any number that can be rewritten in A plus BI form, where A and B are real numbers, and I is just our imaginary component. So for example, 7 plus 2i. Okay, 7 is a real number, and then this is called our imaginary component, okay? We have a real number in front of an I, so 7 plus 2i. That's called a complex number. It's where you mix a real component and an imaginary component. And then here's some other examples. Okay, so anyway, if you look at number 1, it says the directions for number 1 and 2, although we're just doing the odds, it says perform the indicated operation and write your answer in A plus BI form. Okay, this is a complex number. Now you can see here we have a complex number minus another complex number. And I have a feeling a lot of you guys could do this on your own without me saying anything. So why don't you try it? Why don't you just see if you could subtract this complex number from this one? Okay, so in order to do so, now remember, if you have a negative in front of a parenthesis, you have to distribute that to both terms. This parenthesis has a positive 1 in front of it, so basically you could just, if you distribute a 1 inside the parentheses, it stays the same. So you can really just drop the first parentheses. So we have 3 plus 5i. Okay, now when we distribute this negative, negative times 8 would be negative 8. And then negative times negative 8i would be positive 8i. And then from here, we just combine our like terms. So I can combine the 3 minus 8 to give me negative 5. And then I can combine the 5i plus 8i to give me 13i. Now, I just want to point something out. Because they say to write this in A plus BI form, you want to have your term with the I with it, the term with the I on it second, and you want to have your real component first. So this is our real component, negative 5. And then this is our imaginary component, the positive 13i. So this is in the order we want it. So that's it for number 1. All right, if you take a look, so again, we're just doing the odds. If you take a look at number 3, it says perform the indicated operation and write your answer in simplest form. Okay, so here we have a complex number, okay, although y is a variable in this, so it means we're going to have y's in our answer as well. But they're telling us to take this binomial and square it. All right, so if something's squared, it means we have 2 of them. So let's write it out twice. So 2 minus yi times 2 minus yi. All right, and we can just double distribute. So 2 times 2 is 4. 2 times negative yi would be negative 2yi. Okay, you always put the I at the end of the expression. I know we usually put things alphabetically, but this is representing, not a variable, but it's representing the imaginary component. So we always put the I at the end. Okay, and then negative yi times 2 would be another negative 2yi. And then negative yi times negative yi would be positive. Well, y times y is y squared. And then I times I is I squared. So that's what we have so far. All right, so now let's just combine our like terms. So I'm going to take this 4 and bring it down because we don't have any other terms that combines with. And then I can combine the negative 2yi and the other negative 2yi to give me negative 4yi. And then here, if you recall, okay, if you have an I squared is equal to negative 1. Okay, this right here, this I squared is equal to negative 1. Okay, you know what? Here, write this on your paper, put stars around it. That we have to know, okay? You don't ever want to leave yourself with an I to any power within an expression, okay? If you see an I squared, you'll see we might even see I cubes. We want to get rid of that, okay? So what we're going to do is wherever we see an I squared, we're going to replace it with a negative 1. Now let's think about this. This will be positive y squared times, and I should really put this in parentheses, times negative 1. So positive y squared times negative 1 would just be negative y squared. So I'm going to bring down the negative y squared. And then if we look, we don't have any other like terms to combine, so this would be our answer. All right, that's our answer in simplest form. Okay, why don't you guys try out number 5? Number 5 is similar to what we did in number 3, except in number 3 it was squared, so we had 2 of them. In number 5, it's cubed, so you're going to have 3 of them. So remember, you're just going to multiply 2 of them out at first, 2 of the parentheses, get an answer, and then multiply it by the 3rd parenthesis. Okay, so try that on your own. All right, so let's see how you did. So we know that if it's being raised to the 3rd power, we're going to have 3 of these parentheses. So I'm going to take it and write it out 3 times. Okay, so, I mean, you could pick, it doesn't matter where you start, but I'm going to multiply together these first 2 parentheses, get an answer, and then when I'm done, I'll multiply that answer by the 3rd parenthesis. All right, so we're just going to double distribute. 1 times 1 is 1. 1 times negative I is negative I. That's supposed to be a 1, doesn't really look like it. Negative I times 1 is negative I. And negative I times negative I would be positive I squared. Okay? Now, let me work with this parenthesis a little. I'll bring down the 1 minus I. Okay. Now, I'm going to write 1, and then negative I and negative I, these are like terms. So negative 1i minus another 1i would be negative 2i. And then if you remember, isn't I squared equal to negative 1? So this should say minus 1. Okay, and then I'll bring down that other parenthesis. Now, this problem just became easier than we thought because, think about it, within this parenthesis, doesn't 1 minus 1 cancel? Right? The 1 minus 1 cancels. So really, we're left with negative 2i from the first parenthesis, and that's what we're going to distribute in to that last parenthesis there. Okay, so now let's just multiply. Negative 2i times 1 would be negative 2i. And then negative 2i times negative I would be positive 2i squared, right? Don't forget about the square because I times I is I squared. Now, since we know that I squared is equal to negative 1, here, I'll put this right here. Okay, so I squared is negative 1. Well, that leaves us with negative 2i. And then isn't a positive 2 times a negative 1 negative 2? Okay, so we have negative 2i minus 2. Now, you always want to rearrange it in a plus bi form. So you want to have your real component first, and then that imaginary component second. So when I go to rewrite this answer, I'm going to come up here. I'm going to put the negative 2 first, and then the minus 2i second. Okay, that way we have it in a plus bi form. Okay, and I know it says plus, but here you're really adding a negative 2. That's why we have a minus sign. So negative 2 minus 2i would be the answer. Okay, and then I wanted you to try out number 7 on this page. So you could try this out on your own as well. And there's multiple choice, so you know, if it matches up with one of those, you may have gotten it right. If it doesn't, then you got to go back and try to find your mistake. Okay, so since this is being squared, we know we have two of them. So I'm going to take the 3k minus 2i, and I'm going to write it out twice. Okay, and then we're just going to double distribute. So 3k times 3k would be 9k squared. 3k times negative 2i would be negative 6ki. Remember, you put the I at the end. Negative 2i times 3k, again, would be another negative 6ki. And then negative 2i times negative 2i would be positive 4i squared. Okay, now, since we have an I squared right here, okay, right there, we know that this is equal to negative 1. So let me bring down my 9k squared. I can combine the negative 6ki and the negative 6ki to give me negative 12ki. Oh, my pen is not drawing. There we go. And then positive 4 times negative 1 would be negative 4. All right, and it looks like there's nothing else we can combine, so this matches up with choice 3. Okay, now, if you're in the regular or the lab, you can stop here. And if you're in the honors, I'd like you to try out number 8. Number 8 gets a little tricky. And when you're done, I'd like you to check your work with the answer key under the Unit 4 handouts on Google Classroom, and you can check, it's called complex numbers, imaginary and complex numbers. You could check how you did.